As you build various classes, you may notice that some of these classes might have one or more features or functions in common. Here's an example. I'm going to create a class called mammal. All mammals should be able to eat, right? So let's define a function called eat. And in this function, we simply print eat. Now, all mammals, as far as I know, should be able to walk. So let's define another method, walk. And in this method, we print walk. Now, I'm going to select all this code and hold down Shift, Alt, and down arrow to duplicate this class. Now, let's rename this second class fish. As we know, all fish should be able to eat, but fish don't walk, they swim. So let's change the second method to swim, as well as this message that we print. Now, what is going on here? As you can see, we have repeated or duplicated the eat method in both these classes. Now, in this implementation, our eat method is only a single line of code, but in a real-world program, you might have a method that is 5 or 10 lines of code, and you might have repeated that in multiple classes. This is bad, because if there is a bug in one of these methods, you have to fix it in multiple places. Or similarly, if you need to change the behavior of this method, then again, you have to do it in multiple places. In programming, we have this concept called DRY, which stands for don't repeat yourself. So we don't want to repeat ourselves. To solve this problem, we have two solutions. We can use inheritance or composition. In this lecture, we're going to look at inheritance, and I'm going to talk about composition later in this section. Inheritance is a mechanism that allows us to define the common behavior or common functions in one class and then inherit them in other classes. Here's how it works. So I'm going to define a separate class called animal and then move the eat method in this class, like this. Now you can see our mammal class is simpler. So to have it inherit the eat method from the animal class, we simply add parentheses here and then specify the animal class. This is inheritance in action. We say the mammal class is an animal, so it inherits all the features or all the methods of the animal class. In this situation, we refer to the animal class as the parent or base class and mammal as the child or subclass. So let's go ahead and apply the same change on the fish class. We get rid of the eat method and add animal as the base class. Now, when we create a mammal object like M, you can see this mammal has both the eat and walk methods. So let's call eat, run the program. We see this message on the terminal. So this verifies that our mammal class inherits from the animal class. Now, this inheritance is not limited to methods. We can also inherit the attributes of a base class. For example, back to our animal class, I'm going to define a constructor. And in this constructor, let's set age to 1. Now, when we create a mammal object, our mammal object will automatically have the age attribute initialized to 1. Let me show you. So back here, let's print m.age. There you go. Run the program. Here's the result. So this is the basic of inheritance. Now, in real programs, we don't build animals or mammals or fish, unless we're building a game. But I use this as an example because it's easier to understand the relationship between a mammal and an animal. Later in this section, I'm going to give you a real-world example of inheritance in our programs.